You just want to go ahead and break that apart and separate it, so that will give you y is equal to the natural log of t plus the 3 comes in front of the log piece, so it would be 3 times the natural log of t squared plus 3. Now I wanted to make sure I picked this one because inside here you cannot separate this. You cannot expand this out. It has to stay that way. But it's fine because we can go through and do this. Then I just go ahead and get the derivative. The derivative of the natural log of t is just 1 over t. And then with this, I want to do this one separately. I want to go ahead for this portion, u is equal to t squared plus 3. So the derivative of u is equal to 2t. So we're using the chain rule with this. The 3 stays there. The derivative of the natural log, that becomes 1 over t squared plus 3 times 2t. So the derivative is 1 over t plus 6t plus t squared plus 3. Go ahead and do step 1 with this is we have to find the derivative. And then what we do is, because the derivative is, this gives me the slope of the tangent line. Now, once you have that, you find f of 1. And that will give you the slope. Yes, the slope is going to be will be in terms of sine or cosine, or maybe a natural log. It depends on how we get the derivative. And then step 3 is we need to use the equation of the line once we have the find slope. Remember, that's going to give you m. So then we're going to use y minus y1 is equal to mx minus x1 to find the equation of the tangent line. I want to go ahead and this is going to be u, and this will be v. So to start with that, if I have u, that means the derivative of u, and when you're doing the derivative of the u, remember you do need the chain rule. Again, the derivative of the sine is the cosine of 2x, but you have to multiply that times 2 because it's times the derivative of the inside. So the derivative of u is 2 cosine of 2x. Now for v, I do the same thing. The derivative of v is 1 over, all right, hold on, let me take a step back. Inside here, you have that u piece here, which is x squared. And then the derivative of that is equal to 2x. So the rule that we're using with the logs, let me take a step back. If you ever have the natural log of u, d dx of the natural log of u is equal to u prime over u. So this gives us d dx of the natural log of x squared gives us 2x over x squared. So that gives us v prime is equal to 2 over x. So what I have here is u is equal to the sine of 2x. The derivative of that is 2 cosine of 2x. V is the natural log of x squared. The derivative of v is 2 over x. So I need to use the product rule. The product rule, I have one of those and one of those that I multiply together. Now, before I do this, I'm going to just use this property of logs. I'm going to take that 2 and pull the 2 out in the front. So really I'm going to make that equal to 2 natural log of x. You'll get the same answer either way. But then I go through and u prime is equal to the sine of 2x. And I multiply the sine of 2x times 2x. So I'm just going to put that 2x out front. I add that to my other product, the 2 cosine of 2x times, and you can use either the natural log of x squared or 2 natural log of x. It does not matter which one you use for it, because when you go through and plug that in, you're going to get 2 cosine of 2x times 2 natural log of x. Now, for the first derivative test, we want to go ahead and plug in 1 everywhere we have x. So the slope at 1, 0, let x equal to 1, and I get 2 over 1 times the sine of 2 plus 2 cosine of 2 times 2 the natural log of 1. Now, what's really nice here is that the natural log of 1 is equal to 0, which gets rid of all of that. And now my slope is equal to 2 sine of 2. Now I need to go ahead and find the slope, the equation of that line. So that equation of that line, I just use point slope formula. Y minus y1 is equal to mx minus x1, knowing that this is x1 and y1 over here. So y1 is 0. I am just left with y is equal to 2 sine of 2 times x minus 1. And this is not inside that argument. Just the same way I would take the slope and multiply times both of those, I would want to go ahead and multiply that back out. So now I have 2x sine of 2 minus 2 sine of 2.